Let's use a NOR gate to make an inverter. You can do that? Yes, you can. Okay, but I want to see rock-hard, solid proof of it. Okay then, let's do that. First, let's take a look at an inverter. Here's an inverter over here. So, if I have a 1 on, the 1 travels along this line, hits the inverter, is changed into its opposite state, 0, and the light goes off. If I change the switch to a 0, 0 goes along the line, it hits the inverter, it switches to a 1, the opposite state, and the light goes on. Lights go on when there's a 1. Now let's perform this function using a NOR gate. How do we do that? We take the switch, we split the signal, and hook up the switch to both input ends of the NOR gate. So when there's a 1, when the switch is on, when there's a 1 signal comes out, hits this input, splits, and hits this input also. A 1 or a 1 is always a 1. It is then inverted to a 0 and the lights go off. That is an inverter. So now let me change the switch to a 0. 2 zeros hit the inputs of the OR gate. 0 or 0 is always a 0. It's then inverted to a 1 because this is a NOR gate and the lights go on. That is an inverter. So let's draw that. Here's A. It splits right here. It hits the OR gate, which is NORed on the end, negated on the end. And this becomes A ORed with A naught. This becomes A ORed with A. And the output right here means take the quantity and not it. Invert it. Okay, we just did that. Let's now logically prove this. We have A or A quantity knotted. De Morgan's law says if you knot the entire output, you can divide it here at the operator. So let's divide this up. A naught, and the OR is changed into its opposite, which is an AND. You have A naught and A naught. Now, what do we do with this? We use a little bit of Boolean algebra. Let me take the factor A naught, and I'm going to multiply it by something that will give me A naught. What can I multiply A naught by to give me A naught? And the answer is 1. Bring down the AND. A naught times what will give me this A naught? And the answer is 1. Now, if you take 1 and AND it with a 1, what's going to happen? Let's go over here and find out. Here I have a 1 coming into this AND gate, and I've got a 0 coming onto the other AND gate. I'm going to change this to a 1. What happens? 1 ANDed with 1 always gives me a 1. So I can rewrite this over here as A naught and 1. Well, what happens if you AND anything with a 1? Let's go over here and find out. Let's say that A naught is a 0. 0 and 1 is a 0. Hey, that's what was in A naught to begin with. Let's change A naught to a 1. 1 and 1 is a 1, which is exactly what was in A naught. So, if you AND 1 with anything, you're always going to get back that anything, which in this case is A naught, as you can see for yourself right here. So this entire expression up here evaluates or simplifies to A naught. It started out as A and it became A naught. That, my friends, is an inverter. No more, no less. Thanks so much for listening, and I'll see you in the next video. Bye-bye now.